When comparing variation in two different data sets, the standard deviation should be compared only if the two sets of data use the same scale and units and they have approximately the same mean. If this is not the case, we can use the coefficient of variation to compare variation in the two sets of data. So the coefficient of variation describes the standard deviation relative to the mean of the data. So for a sample coefficient of variation, we would calculate the coefficient of variation, abbreviated CV, as the ratio of the sample standard deviation over the sample mean. So as we said, it's the standard deviation relative to the mean. And then we want this as a percent, so we'll multiply by 100%. For a population, the coefficient of variation is just equal to then the population standard deviation, sigma, over the population mean, that ratio, times 100%. Okay, so let's look at an actual example that we might encounter. So uniform manufacturers need good statistical data with respect to body measurements. The following statistics were collected for adult female leg lengths and arm lengths. Which data set has the least amount of variation? So let's get this information. So for the leg length, here were the results. There were 100 values in the data set, or 100 women were measured, their leg lengths were measured. They found the mean leg length, let's just write them here, the mean was equal to 40.49 inches, and the sample standard deviation of the leg lengths was 4.59 inches. And then for arm length, let's change colors here. Arm length, they found in their sample of 100 to have a mean arm length of 29.43 inches and a sample standard deviation of 3.62 inches. Okay, so even though both of these are in inches, we're talking about two different body parts, and also these means are very different. So in order to compare, we can't just look at this and say, oh, 4.59 is a larger number than 3.62. They're both inches, so we might think we could do that comparison. So therefore there is more variation in the leg length data than in the arm length data, but that may not be the case, and we need to calculate the coefficient of variation for this data set. So let's do that for the leg. The leg CV, then we said, would be the sample standard deviation divided by the mean times 100%. And in this case, for leg, sample standard deviation 4.59 divided by the mean 40.49 times 100%. And I'm going to round to 2 decimal places and get 11.34%. Okay, so that's the coefficient of variation for the leg lengths. For the arm lengths, the arm CV, standard deviation over the mean, times 100%. So here our standard deviation, 3.62 divided by 29.43 times 100%. And this time, rounded to 2 decimal places, I get 12.30%. So even though the standard deviation was smaller for arm lengths, there's more variation in the data. The data tends to be more spread out, more dispersed than it is in the leg lengths. So this is how we can use coefficient of variation to compare two data sets, the variation in two data sets.